Good afternoon all. We are moving to second semester portions. The paper's title is Calculus of Single Variable 1. You have already studied in plus 2 the differentiation and integration, all that will be there, and some applications of integration and differentiation. So we are moving to module 1. Module 1, in the module 1 we have to define a function. What's a function? So this you have already studied. Given two sets x and y, a function from x to y is a correspondence which associates with each element of x, one and only element of with each element of x, one and only one element of y, denoted by f from x to y. Read us. So some s is missing. F is a function from x into y. The set x is called the domain of f and y is called the codomain of f. If f of x equal to y, then y is called the image of x and x is the pre-image of y. Also we have one more definition. The range of f is a set of f of x element of x. This is the definition of range. So you have a definition of function, what is the domain and what is codomain, what is an image, pre-image and range. That's much definitions you have to learn. Now we have to learn the definition of real valued functions. So when x and y are real values, it is called the real valued functions. So if a function with the domain and y, the image function, is real valued functions, then it is called real functions. If y equal to f of x, then x is called the independent variable and y is called the dependent variable. So you have a problem. Find the domain and range of the following real valued function. F of x equal to 1 minus root of x. Second problem, g of z equal to 1 by square root of 4 minus z square. In the first function, f of x equal to 1 minus root x. Per domain എന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ അതിൻ്റെ all possible x values കണ്ടുപിടിക്കുക എന്നുള്ളതാണ്. Range എന്ന് വെച്ചാൽ all possible y values. So ഇവിടെ നമ്മുടെ ഫംഗ്ഷൻ എന്ന് പറഞ്ഞാൽ 1 minus root x ആണ്. അതിൽ since square root of a negative number is not a real number, f of x is a real number only if x greater than or equal to 0. Hence, the domain of the above function is the set of all negative real numbers, that is, domain of f equal to closed interval 0 infinity. Now 0 less than or equal to x less than infinity, that is 0 less than or equal to root of x less than infinity. നമ്മൾ ഇനി അതിൻ്റെ നെഗറ്റീവ് എടുക്കുകയാണെങ്കിൽ മൈനസ് ഇൻഫിനിറ്റി ലെസ് ദാൻ മൈനസ് റൂട്ട് എക്സ് ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 0, ദാറ്റ് ഈസ് മൈനസ് ഇൻഫിനിറ്റി ലെസ് ദാൻ 1 മൈനസ് റൂട്ട് എക്സ് ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 1, ദാറ്റ് ഈസ് മൈനസ് ഇൻഫിനിറ്റി ലെസ് ദാൻ എഫ് ഓഫ് എക്സ് ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 1. നമ്മുടെ എഫ് ഓഫ് എക്സ് എന്ന് പറഞ്ഞാണ് y വാല്യൂസ്, ദാറ്റ് ഈസ് റേഞ്ച് ഓഫ് എഫ് ഈക്വൽ ടു മൈനസ് ഇൻഫിനിറ്റി ഓപ്പൺ ഇൻ്റർവൽ മൈനസ് ഇൻഫിനിറ്റി ക്ലോസ്ഡ് ഇൻ്റർവൽ 1 ക്ലോസ്ഡ്. ഇനി അടുത്ത പ്രോബ്ലത്തിൽ g of z equal to 1 by square root of 4 minus z square. അതിൻ്റെ ഡൊമൈനും റേഞ്ചുമാണ് കണ്ടുപിടിക്കേണ്ടത്. Since square root of a negative number is not a real number and division by 0 is not defined, g of z is a real number only if 4 minus z square greater than 0. 4 minus z square greater than 0 implies this z square should be less than 4. That is minus 2 less than z less than 2, taking the square root. That is domain of g is the open interval minus 2 2. Now minus 2 less than z less than 2, which implies 0 less than or equal to z square less than 4. നമ്മൾ ഇനി അതിൻ്റെ നെഗറ്റീവ് എടുത്തു. minus 4 less than minus z square less than or equal to 0.
ഇനി നമ്മൾ 4 വെച്ച് ആഡ് ചെയ്തു. 0 ലെസ് ദാൻ 4 മൈനസ് ഇസഡ് സ്ക്വയർ ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 4. ദാറ്റ് ഈസ് ഇനി അതിൻ്റെ റൂട്ട് എടുത്തു. 0 ലെസ് ദാൻ സ്ക്വയർ റൂട്ട് ഓഫ് 4 മൈനസ് ഇസഡ് സ്ക്വയർ ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 2, വിച്ച് ഇനി അതിൻ്റെ റെസിപ്രോക്കൽ എടുത്തു. ഹാഫ് ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 1 by square root of 4 minus z square less than infinity. That is half less than or equal to g of z less than infinity. That is range of g is closed interval half of infinity open.
So we have to remember one thing, for real functions this should be the range and domain should be greater than or equal to 0. Now we have the algebraic operations of real functions. If f and g are functions, then f plus g, f minus g, fg different for every x that belongs to the domain of both f and g by f plus g of x, which is equal to f of x plus g of x. F minus g of x equal to f of x minus g of x. Product f g of x equal to f of x g of x, and at any point of domain of intersection domain of g at which g of x not equal to 0, f by g of x equal to f of x by g of x, provided g of x not equal to 0. And next scalar multiplication. If c is a real number, then cf of x equal to cf of x. We have problems. Find f plus g, f minus g, f g and f by g and their domains for the following functions. So first one, f of x equal to x square minus x, g of x equal to x plus 5. Second problem, f of x equal to square root of 1 plus x, g of x equal to square root of 1 minus x. Given that f of x equal to x square minus x and g of x equal to x plus 5. First we have to find the domain of f of x and g of x. Here f of x is equal to x square minus x, or the all possible values of x is equal to for all real numbers we can define the f of x. That is domain of f equal to minus infinity to infinity, and domain of g is also equal to minus infinity to infinity. Now domain of f plus g equal to domain of f minus g equal to domain of f g equal to domain of f intersection domain of g, which is equal to minus infinity infinity. Hence for every real number x we have f plus g of x equal to f of x plus g of x. Here f of x is x square minus x and g of x is x plus 5. So sum is x square plus 5. Now f minus g of x equal to f of x minus g of x, which is equal to x square minus x minus of x plus 5, which is equal to x square minus 2x minus 5. Now f g of x equal to f of x into g of x, which is equal to x square minus x into x plus 5 equal to x cube plus 5x square minus x square minus 5x. Simplification we get x cube plus 4x square minus 5x. Now domain of f by g of x equal to domain of f intersection domain of g minus x such that g of x equal to 0. Here g of x equal to x plus 5, which is equal to 0 when x equal to minus 5. So minus infinity infinity minus singleton set minus 5. Which is equal to minus infinity minus 5 union minus 5 infinity. So f by g of x equal to f of x by g of x, which is equal to x square minus x by x plus 5. And the problem, f of x equal to square root of 1 plus x and g of x equal to square root of 1 minus x. We have to find f plus g, f minus g, f g and f by g of x. നമ്മൾ ആദ്യം ഇതിൻ്റെ ഡൊമൈൻ കണ്ടുപിടിക്കുക. ഡൊമൈൻ f of x is square root of 1 plus x. Since square root of a negative number is not a real number, f of x is defined
only for those values of x for which 1 plus x greater than or equal to 0, that is x greater than or equal to minus 1. Therefore, domain of f is the set of all x values for which x greater than or equal to minus 1, that is closed interval minus 1 infinity. Similarly, g of x is defined only for those values of x for which 1 minus x greater than or equal to 0, that is when x less than or equal to minus 1. Therefore, domain of g is equal to minus infinity minus 1, closed interval minus 1. Hence, domain of f plus g is equal to domain of f minus g is equal to domain of fg is equal to domain of f intersection domain of g. Therefore, closed interval minus 1 infinity intersection minus infinity 1, which is equal to closed interval minus 1 1. Therefore, f plus g of x is equal to f of x plus g of x is equal to square root of 1 plus x plus square root of 1 minus x for all x element of minus 1 1, and f minus g of x equal to f of x minus g of x, which is equal to square root of 1 plus x minus square root of 1 minus x for all x element of minus 1 1, and fg of x equal to f of x into g of x equal to square root of 1 plus x into square root of 1 minus x, which is equal to square root of 1 minus x square for all x element of closed interval minus 1 1. Now we have to find f by g of x. For that, first we have to find the domain of f by g of x. Domain of f by g of x is defined as domain of f intersection domain of g minus x such that g of x equal to 0. Here g of x equal to square root of 1 minus x, and which is equal to 0 when x equal to 1. Therefore, domain of f by g of x equal to closed interval minus 1 1 minus singleton set 1, which is equal to closed interval minus 1 1 open 1. Therefore, f by g of x equal to f of x by g of x equal to square root of 1 plus x by square root of 1 minus x for all x element of closed interval minus 1 1 open.
Next we have the definition of composite of functions. So if f and g are real valued function, then the composite of functions g composite of f is defined by g small o f of x equal to g of f of x, and the domain of g of f consists of numbers x in the domain of f for which f of x lies in the domain of g. So we have a problem. Let f and g be real numbers defined by f of x equal to x square and g of x equal to 2x plus 3. Find f composite g and g composite f.
Now we have to find the composition of functions given f of x equal to x square, g of x equal to 2x plus 3. Domain of f is equal to set of all possible values for x equal to minus infinity infinity. Similarly, domain of g is equal to minus infinity infinity. Range of f equal to its value is square, so the range is closed interval 0 infinity, which lies in minus infinity infinity. Hence, domain of g composite f is domain of f, which is equal to domain of g composite f is minus infinity infinity. Now g composite of f of x equal to g of f of x, which is equal to g of x square, which is equal to g of x is 2x plus 3, x in a x square substitute. So 2x square plus 3. Now range of g is equal to minus infinity infinity, which is equal to domain of f. Therefore domain of f composite g is minus infinity infinity. Now f composite g of x equal to f of g of x, which is equal to f of g of x is 2x plus 3. F of x is x square. Therefore f of 2x plus 3 is 2x plus 3 whole square.
So we have noted that f composite g of x not equal to g composite f of x. Now we have composite of three functions. If f, g and h are three functions, then f composite g composite h of x equal to f of g of h of x. Now the problem is, let f of x equal to root of x, g of x equal to 2x plus 1 and h of x equal to x square minus 1. Find f composite g composite h.
F of x തന്നിട്ടുണ്ട് root of x, g of x equal to 2x plus 1, h of x equal to x square minus 1. We have to find f composite g composite h of x, which is equal to f of g of h of x, which is equal to f of g of, നമ്മൾ റൈറ്റ് സൈഡിൽ വേണം ആദ്യം സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാനായിട്ട്. h of x is x square minus 1. ഇനി g of x ന്റെ വാല്യൂ 2 of x plus 1. അവിടെ ഈ എക്സിന് പകരം x square minus 1 സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. ദാറ്റ് ഈസ് 2 into x square minus 1 plus 1. Which is equal to, substitute here, f of 2 into x square is 2x square minus 2 plus 1, which is equal to f of 2x square minus 1. Here f of x in the value root x ആണ്. So this will be square root of 2x square minus 1.
Now we have the definition of even and odd functions. A function f is said to be an even function if f of minus x equal to f of x. Example, x square plus 4 cos x. പിന്നെ എല്ലാ കോൺസ്റ്റന്റ് ഫങ്ഷൻസും ഈവൻ ഫംഗ്ഷനാണ്. എക്സ് സ്ക്വയർ, എക്സ് റേസ് ടു 4, എക്സ് റേസ് ടു 6 ഈവൻ പവർ ആയിട്ട് വരുന്ന എല്ലാ ഫംഗ്ഷൻസും ഇസ് ഈവൻ ഫംഗ്ഷൻസ്. എ ഫംഗ്ഷൻ എഫ് ഈസ് സെഡ് ടു ബി ആൻ ഓഡ് ഫംഗ്ഷൻ ഇഫ് എഫ് ഓഫ് മൈനസ് എക്സ് ഈക്വൽ ടു മൈനസ് എഫ് ഓഫ് എക്സ്. Example, f of x equal to x cube plus 4x sin x. x raised to odd function വരുന്നതെല്ലാം ഓഡ് ആയിട്ട് വരുന്നത്, x raised to odd ആയിട്ട് വരുന്നതെല്ലാം ഓഡ് ഫങ്ഷൻസ് ആയിരിക്കും. അത്രയാണ് ഇന്നത്തെ ക്ലാസ്സിലുള്ളത്.